Hey guys, we're going to be looking at proportional reasoning. Now, I do want to warn you, this stuff is going to look pretty simple, but it's being presented here more, as a platform to build on, okay, as we move along. So you really get this down, and here's some vocabulary in front of you. Like always, you're encouraged to kind of look it up, get acquainted. Look for definitions, Google or your online textbook. And what else was I going to say? And for examples. Alright, let's get into it. So solve the proportion. So as you can see, we've got this ratio, these fractions. It's very important to solve problems involving these. You'll really be required to do so with the material we're going to be looking at the next couple of days, okay, for the rest of the week. So anyways, solve the proportion. I think a lot of you guys already know what to do. So the question is, what do you do? Right? There's different ways to describe it, but many people would say kind of cross multiply. So that would be correct. Essentially, I could multiply, pay attention, to both sides by 8, which would cancel this one, and then again both sides by 16 to cancel it out here. But that shortcut is indeed that. Okay? So let me go and do it exactly like this. Okay, most of you guys would do this. Right? And then you'd get an answer of x equals 8. Correct? Again, how did that happen? Multiply and multiply. What I'm going to do here, though, because it is important that not only do you know the trick, but the rationale, is if I have this guy, I could technically multiply by 8. Okay. So, let me see here. I may take an image of this thing here real quick. So I don't get too sloppy. And again, the whole point here is to really be masterful with your understanding. So I'm avoiding just the shortcut. All for little payoff, okay? Down the line. So, because it is an equation, I can continue doing the same thing over and over to both sides and not lose equality, right? So, why the 8? So I can cancel out here. That's the only reason. And to be fair to the equation, I'll do it to this side. And then I'll do a times 16 over here. Why? So I can cancel out here only. And to be fair to the equation, I'll balance it out with that. So sure enough, that cancels. That cancels. And I'm still left with the afterthought of this shortcut, right? So 4 times 16. And the x times the 8. Okay, and then you go ahead and do the simple math there, right? So this times this is what, 64. This is 8x. Divides both sides by 8, and that's where we got the 8. All right, moving on. Let's look at this problem. A high school stadium can seat about 80% of the students attending the high school. If there are 405 students enrolled in the high school, how many students can the stadium seat? If necessary, round to the nearest number of students. Alright, let's see here. Round to the nearest number of students. So, although there's different approaches, let's just pick one and run with it. Alright? So, most of you guys know that when you hear percent, it's out of 100, right? So 75% is 75 over 100, excuse me. So in general, okay, when you're talking ratios, you're talking about the part over the whole. Alright? So this is very basic knowledge that allows you to do very amazing things and organize your thoughts. So I put that in your memory bank somewhere, okay? Somewhere easily and quickly accessible. So anyways, according to the story, all we really got to do is fill in to kind of move on from this problem, right? So when we read it, it says 80%, so there's the percent given, right? 80 out of 100. Done, right? Next, if there are 405 students enrolled, right, you gotta work on your interpretation. Would that be the part or the whole? Okay, if you're thinking whole, good. So the only thing missing is the part, right? And it says how many students can the stadium seat? Well, that right there would be your X. How many? So we're going to go ahead and call it X. So now we just looked at earlier the math behind solving a problem like this. I'll use the shortcut. Okay. Oops, I was going to put 80x. Don't want to go too fast. Right. So you do want to cross multiply it this way. So I've got 80, 405, and I've got 100x. I can go ahead now and do the multiplication. Let's see, give me a second here. It's really just 8, add a 0 at the end. Alright, so let's put the 0 there. So we get 40, and then 320. Now divide both sides by 100. And we're left with 324 equals x. Okay, so there's the math, but really we should be saying that 324 students can be seated at the stadium. Alright, let's move on to one more here. Lydia's training for the half marathon, a 13-mile long race. This morning she ran 8 miles in 58 minutes. Assuming she can maintain this pace, how long will it take her to run the half marathon? Now again, what you're about to see is very powerful. Why? Because fractions, ratios, things like that, they're not as intuitive as a lot of other stuff for you guys. Okay? So let's go ahead and take the ratio that we do know, right? So it says 8 miles in 58 minutes. Okay, so that's one comparison that we can make here, right? So for 58 minutes, what did she accomplish? 8 miles. Alright, so this is information that we can use to make estimations of other scenarios. So for example here, it's 13 miles. Okay, that is our concern, but there is no time frame for it. So it says how long will it take to run the half marathon? Well, good old X seems appropriate there. And once you do that, then you can go and continue with the math and set that up. Okay, so let's go ahead and cross multiply here. 58 times 13 equals 8x. And let's go and do some quick math here. What do we get? Let me leave it intact. 8x. I don't want to make a quick simple math. 754. Now we can divide by 8. What do we get? 92.2. Let me scratch that. And again, we can hit calculator. I was trying to save some time here. So this is roughly that. Okay. X is approximately 94. Okay. So there's the math once again. In terms of rationale, it says how long will it take her? It would only seem appropriate to what? 5 minutes here in that case. Guys, thanks for your time and good luck on tomorrow's warm-up. Okay, and let's have that discussion in class. Goodbye.